So in today's lesson, we are going to learn about hypothesis testing with the normal distribution. And here, what we are going to do, we'll collect some sample from the population. So if this is a population here, this is a population, there are 50 people. So I have collected 10 people here. So 10 people, this is population. Okay. And this is sample. Okay. So we have collected 10. So now here from sample we are going to find mean. So it will be called sample mean. Okay, sample mean. Okay, and the random sample, if we select from here random sample, from this sample we are going for random sample. In short, we can say RV. Yeah. So and if its size is n, random sample, and if its size is n, okay, so then for any random variable, normal distribution is given by mu and sigma square. Okay, and for the sample mean x bar, for this sample, if we are finding mean, then it is going by sample mean. Sample mean is given by, normally it is mu sigma square, and sigma square should be divided by n because we have taken out n sample. So for a random sample of size n, if you see this definition, for a random sample of size n taken from a random variable x, and the sample mean is x bar, capital X bar is sample mean. It is normally distributed and it is given by this formula: x bar distributed normally, mu and sigma square divided by n. Okay, so there are 6 steps which we need to follow for this topic. I'm going over with all the steps one by one. So 6 steps which we are going to follow in this topic. First one is step 1, that is define random variable. That is our first step. RV, random variable, define random variable. Second step is define distribution. Okay, define distribution for x. So x is distributed normally, that is mu and sigma square, that is variance. Third step is define distribution for sample mean. Define distribution for sample mean. And as I said, sample mean is denoted by x bar. So x bar distributed normally, it is mu and sigma square divided by number of samples n. Fourth one is write down your hypothesis. Write down your hypothesis. Yeah, hypothesis. So you are going to write down hypothesis in terms of null hypothesis and alternative hypothesis, right? So here you are going to write down H0 and H1. Okay, we are dealing with the mean, so we can write down here mu will be something or mu can be greater than something. Is that okay? So if mu is greater, then we are going to test for increase. Test for increase. I'm going to underline, if you see increase word means it is one tail test, yeah, towards the top end, because here is a greater than sign. Okay, this is points for the 4. Next one, H0 equal to mu is always equal. Then H1 can be mu less than, so it is test for decrease. So it is towards the lower end, test for decrease, right? And the last one is we have considered both tail test. This is one tail test, this is one tail test. Now next one is two tail test. So two tail test, H0, mu will be something and mu should not be equal to. When it is not equal to, it is two tail test, right? So in this case, what you need to do, you need to find probability. It is two tail test. find probability. If you're finding probability in all these cases, yeah, if you find probability in all these cases and it is coming like this, probability which is less than significance level. SL stands for significance level. I'm writing in short significance level. If probability is less than significance level, so what we do? We do reject HO and accept H1. And when probability is greater than and equal to significance level, then we say accept HO and reject H1. This is 0.4, right? So 0.4, where you are going to test for hypothesis, whether it is one tail test or no two tail test, decide and find whether your probability, what you are finding, it is less than significance level or greater than significance level. If it is less than significance level, then we need to reject HO and accept H1. If it is greater than and equal to significance level, accept HO and reject H1. Okay. Now, after fourth point, fifth point is, so fifth point, just have a look. So it is fifth point, calculate your probability and compare with significance level. So this is your fifth point. Calculate your probability and compare with significance level. This is fifth point. Compare your probability, what you found, with significance level. And the last one is, last step, to write down this step, you'll get 1 marks. You need to write down the statement conclusion in context. What is the conclusion? So that you need to write down conclusion in context. Okay, these are the 6 steps which we are going to follow when we are using hypothesis testing in normal distribution. Is that okay? So let's see questions straight away. Okay, so here's a question. So null hypothesis mu 15, alternative hypothesis mu less than 15, n is 30, standard deviation sigma is 1.5, x bar, that is sample mean, is 14.5 and significance level is 1%. Okay, so first of all, our first step is, I'm writing a step here, let x be random variable. Okay, that is our first step. Second step is, we need to write down normal distribution. So x is distributed normally and we know it is mu and sigma square. So mu is 15 and sigma is 1.5. So it should be 1.5 square. Okay, if this is correct, you will get 1 mark for writing this. Third step, we need to write down for the sample mean. So x bar normally distributed, mu again. So here, what is the mu here? What is mu here? Yeah, 15, and it should be 1.5 square and divided by 30, because x bar formula is normally distributed mu and sigma square over n. Is that okay? Now, fourth point, we need to decide about the hypothesis testing. So let's write down hypothesis testing. What is H0 here? What is H1 here? So H0 is given mu is 15, right? Mu is 15 and H1 is mu is less than 15. This less than sign is telling you we are going to do one tail test and it is towards the lower end, right? Lower end means if we draw normal distribution curve, that is bell-shaped curve, okay, and mu is 15, so it should be somewhere here. Mu is less than 15, it means this will be our area, right? This will be our area. Now, they are saying you need to find probability when x bar is less than 14.5. Okay, so this 14.5, let's draw it here, 14.5. Okay, so this is 14.5 will be on the left hand side of, is that okay? 14.5. It means we are looking for this red area. Is that okay? Still we are doing 0.4, less than 14.5. So now probability when x bar is less than 14.5. Okay, x bar when it is for, so we are going for menu Casio ClassWiz calculator menu number 7, and we are going for normal CD. Okay, so what is lower value here? What is lower value here and upper value here, guys? So first tell me what is lower value. Oh, upper value. Upper value is 14.5. Upper value is 14.5. Because we are going in this direction, so lower value you can take minus 10, minus 100, minus 1000, anyone, infinite. So let's take minus 1000. Okay, so lower value is this one. Now mu is how much here? 15. Now sigma, which sample, which mean we are dealing here? It is x bar, that is sample mean. And for sample mean, standard deviation is sigma, variance is sigma square divided by n here. So here, this is very important. So here, what will be a standard deviation? Sigma will be square root of sigma square over n. What is sigma here? 1.5 square over 30. So whatever is here, you need to take the square root to get a standard deviation for sample mean. Okay, because we are dealing with sample mean, right? So sigma 1.5 square. So this should be 1.5 over square root 30. Is that okay? No need to simplify. Leave it like this. Okay. Now put this value in a calculator. Sigma is 1.5 divided by square root 30. How much probability is coming? How much it is coming? 0. Decimals 4 places 0.0339. This is what we got probability, yeah. And the last step, this is fourth step. Fifth step is this one. I have done the probability. And sixth step is compare probability with your significance level. Significance level is 1%, that is 0.01, right? Okay, now you need to compare this probability, whether this probability is greater than or less than significance level. Greater than. So greater than, it is 0.01. Greater than 0.01. So what we need to do? We need to accept HO or reject, accept HO or reject HO. Accept HO. Thank you. So we are going to write down accept HO and reject H1. Reject H1. This is not enough. This is not enough. You need to write down a statement why it is. So you can write down there is not enough there is not enough evidence to reject HO. Okay, there is not enough evidence to reject HO. So you can write down here there is not enough evidence to reject HO. This is your question number 1 completed. Any doubt? So this is your question where null hypothesis, alternative hypothesis, and 25 sigma, sample mean, and significance level 5% is given. Okay, so mu is not equal to 120. It means it is telling you two-tail test, right? It is telling you two-tail test. Okay, so when it is two-tail test, so we can go for lower end and upper end, both side. So let's go for the lower end side. Lower end side, so H0 mu is 124, sorry 120. H1 mu is less than 124. So in this case, our diagram will look like this. Okay, so mu is 120. Now 1 to 4, it should be on the right hand side, and we are checking this area. Is that okay? We are checking this area. So in this case, what will be our upper value? Upper value is 124. Lower value is minus 1000. Okay, and mu is 120. And what about sigma? Sigma will be a square root of 12 square, because here it is 12 square if you write down. Yes, so it should be x distributed normally 120 and 12 square, and for sample mean it should be 120 and it should be 12 square over 25. Is that fine? So it should be a square root of 12 square over 25. So it should be 12 over root 25 is 5. Okay. So put this value. How much it is coming probability? Yes. How much it is coming? Yeah, probability. Once you put 0.9522. So 0.9522, it is greater than 0.025. Yeah. Okay. If it is greater than 0.025, what does it mean? Accept HO and reject H1. So accept HO and reject H1. Right? Now, this was lower end. Now, if we go on the top end, so we can draw again this. So mu is 120 degree, 124 is this side. Yeah, it means we are going for this area, but our calculator gives left side of the area, right? Casio ClassWiz gives left side of the area. So in this case, how we are going to find? How you are going to find? So upper value, you have question. Yeah. So upper value is how much? Upper value is, yeah. Here upper value is 124 and lower value is minus 1000, because you are going down, right? Isn't it? And so, and our mu is 120 and sigma will be 12 over 5. So exactly you will get the same thing, isn't it? Because here 124 is on the right hand side, but we have already worked it out. Yeah. Okay. So, and if this area, if you need to find this area, we don't want this area. From 1, if you minus it 0.9522, you will get this area, isn't it? Okay. So from 1, you take away 0.9522. How much it is coming? 0.047. Okay. So 0.047. Okay. Compare it with probability 0.047. It is greater than or less than 0.05. 0.047. And if you compare 0.05, it is greater than or less than. We will use 0.025 because it is two-tailed test. 0.025. 0.025. So it is greater than or less than? Greater. So it is greater. So you are getting the same thing, and you can write down here accept HO and reject H1. Here I have not taken worded problem, so it is difficult to write down the conclusion in context, right? So next question, I'm taking worded problem and then we can write down. Is that okay? Is that fine, guys? Okay. And this part of the question, for upper part, you can use this as well. Here, lower value you can take 124 and upper value in this side plus infinite. So we can take 1000. Okay. And mu is 120 and sigma is 12 over 5, right? And then still you'll get the same answer, right? Yes, Amir? Yes, how much you are getting this when you are taking this value? 0.0478. So All these answers are nearly same. Okay, so you can do it either way, whatever way you like it. Here's a question. Daily mean wind speed is modeled as being normally distributed. So this word is coming. So it is normal distribution question with a standard deviation of 3.1 knots. Yeah. Okay. Standard deviation is 3.1 knot. A random sample of 25. So n is given here. And daily mean wind speed is taken at Heathrow in 2015. Given that the mean of the sample, so mean of the sample is 12.2 knots, test at the 2.5% level of significance whether the mean of the daily mean wind speed is greater than 9.5 knots. State your hypothesis clearly. So what we are checking here? We are checking whether wind speed is greater than 9.5 knots or not. Okay. For this, we are going to do test, hypothesis test. So here we can assume, because let x be a random variable which we are going to find. Okay. Second thing is x is distributed normally, mu and sigma square. What is mu? What is mu here? Mu is greater than 9.5. Yeah. Mu is 9.5. Okay. 12.2 is coming. That we need to calculate. 9.5. And sigma square. Sigma is how much? 3.1 knot. Can you see here? This is 3.1 square. Okay. Third step, x distributed normally. Here we are taking sample mean. It should be mu and sigma square over n. So in this case, x bar will be 9.5, 3.1 square divided by how many? 25. So it should be 25. Is that fine? Now, fourth one, writing hypothesis. So H0, mu is 9.5. So see here, mean of the daily wind speed is greater than 9.5. Okay. So which word they are using here? Greater than. It is one tail test. One tail test towards the right hand. Okay. So one tail test. So H1 will be mu is greater than 9.5. Right? Now, given that the mean of the sample, so this is, Amir, you did the mistake here. Mean of the sample is 12.2 knots. Yeah. So here we need to check, because they are asking greater than. So greater than means mean of the sample, that is x bar. X bar should be greater than 12.2, greater than and equal to. Yeah. You no need to take equal sign here, because equal sign, it is, if you're taking equal sign, it is hardly affecting any answer. So this you can write down P x bar here. Sorry. X bar greater than 12.2. Is that okay? This is what we have done. Now, we need to construct a normal distribution curve, that is bell-shaped curve. So let's do it. Bell-shaped curve. Here. Okay. In this bell-shaped curve, what we need to do, this is our mean, right? This is mean. Mean is how much? 9.5. Okay. Mean is 9.5. So 12.2 will be on the right hand side of this, right? Okay. It means we are looking for this area, isn't it? We are looking for this area. So again, pick up your calculator. So your lower limit will be 12.2. Upper limit will be, if you are going in this direction, so it should be, you can take 1,000, 100, 1 million, anything. So I have taken 1,000, right? Mu is how much here? 9.5. And sigma, remember, whatever is here, you need to take the square root of that. So it should be a square root of 3.1 square over 25. That is 3.1 over 5. Is that okay? Right. If you find the probability, how much probability is coming? So probability when x bar is greater than 12.2 is how much coming? Sorry, say again. So 6.6, if you can round it off, so it should be 0.000, how many zeros? 4, 5 and 7. Can we write down like this? 6.6, yeah, 7. Is that okay? Now, comparison. Aisha, you are not getting this. Oh, thank you. So, this is less than significance level. Significance level was how much? 2.5% here, right? 2.5%. If you see question, here significance level is given 2.5%. Can you see? Yeah. So 2.5%. So we need to compare whether it is less than 2.5%. So it is less than 0.025. Yeah. So when it is less than, it means what? Reject HO. It means accept H1. Now, this is your fifth part, and sixth, this is your probability part is fifth part, and sixth part you need to write down accepting H1. Yeah. Accepting H1 is telling you that mean is increased. Mean is increased. Can you see here? We are accepting H1, and H1 was, what was our H1? If you see here, H1 was mu is greater than 9.5. So it means we are accepting H1, alternative hypothesis. Yeah. Yeah, but it is not a two-tailed test. Yeah, it is greater than. Yeah, thank you for asking. So is that okay, guys? So alternative hypothesis was saying mu is greater than 9.5, and here we found mu is greater than 9.5, right? So we are accepting alternative hypothesis and rejecting HO. So accepting H1 means mean is increased and mean of the daily wind speed must be greater than 9.5. Yeah. So that should be your statement. So you can write down here mean is increased. Increased. It means mean of the daily wind speed. Mean of daily wind speed greater than 9.5. Is that okay? This is what they have asked us to do test. We did test, result is there, and we found that wind mean of daily wind speed is greater than 9.5. Am I clear? Right? Any question? Yeah, you have all this information here. You can, yeah, that you can write down here. That you can write down. Okay. Basically, you need to collect the answer part, what they are asking. Whether the mean of the daily wind speed is greater than 9.5 or not. So your conclusion of context will be the answer what they are asking in the question. So this will be your conclusion of context here. Right? So always, it is always given in the question and you are writing that. Okay. And for writing that, you are getting 1 mark. So please write down, don't be lazy. Okay. Is that fine? So guys, is that okay? Okay, that's it now.